let's welcome Supriti and David and enjoy the talk.
Hello everyone. Hello everyone, my name is Supriti. I work as a software developer at SUSE, and my colleague David, he is also a software developer at SUSE. I have been working on NFS Ganesha for around 1 year now, and David here is a Samba contributor for a long time. Today we want to talk about how Samba and NFS Ganesha work together with Ceph. So today's agenda is very simple. We are trying to find answer for 3 very simple questions: why, what, and how. Why are we talking about Samba and NFS Ganesha with respect to CephFS? What does Samba and NFS Ganesha looks like? What is the architecture? And finally, how these 2 gateways fare with respect to a native CephFS client. I'm sure most of the people are aware about the Ceph architecture. So Ceph is basically a distributed storage system, and you can access the most basic layer RADOS using different interface, and one of them is CephFS. CephFS is a POSIX compliant distributed file system, and there are multiple clients through which you can use CephFS. One is kernel client, then there's also a Fuse client which is not mentioned here, and then there are Samba and NFS Ganesha. So you may ask, why do we need to export CephFS using Samba and NFS Ganesha? Because it would make CephFS available to even a wider variety of clients. So let's say if you have a kernel client which is not up to date, so you can't use the latest kernel CephFS client, and then you don't get the advantage of the latest feature from CephFS, but you can still use NFS because almost all the Linux clients support NFS. Then Samba, you can re-export CephFS in Windows, Mac OS, and Linux, of course. So now I will be talking more about what is NFS Ganesha. NFS Ganesha is an open source user space NFS server. It supports multiple file system backends at this point. There's CephFS, there's RADOS Gateway, Red Hat's Gluster, IBM GPFS. If you were in this room before for Lizard FS, you may be aware that they are also planning to integrate with NFS Ganesha. But today we just want to talk about CephFS. So it's a very simple idea what NFS Ganesha is doing here. It's basically translating the NFS protocol into the language that the RADOS cluster understands, and it's doing so by using the shared library which is libceffs. So let's say you have 2 clients, one is NFS, one is kernel client, and you can mount these 2 clients and you see the same file system. Now we can go in more detail about NFS Ganesha architecture. It's a very modular architecture. So when I said that it supports multiple file system backends, it's possible because it's modular. We can start from topmost and go down. So at the topmost we have a network channel. NFS Ganesha uses TI RPC for all the RPC, for handling the RPC request. So let's imagine you have an NFS client and it sends a request, then this TI RPC is handling the request, then it passes this to a duplicate request layer. So what this does is, for example, you have a non-idempotent request like creating a file, and you know that once a file has been created, it cannot be recreated. So instead of talking again to the lower level and reassuring that, okay, should I create the file or not, you just have a cache in between which makes sure that some response time is better. Then NFS Ganesha also supports RPC sec GSS, which is support for Kerberos. If we go down, then there's support for NFS version 3 and version 4. It actually supports PNFS for Gluster also, but we are talking just for CephFS, so I have not included it. Then So once NFS client has sent an NFS request, the topmost layer is now understanding what the request is, and now it needs to translate that into a language that the file system understands. And that is taken care by the FASAL layer. So FASAL is a common API, and using this API, all the file systems are talking to the NFS topmost layer, and that's why you have multiple backends, because it's just a common API. You use it and you plug in your backend. And the most interesting thing of NFS Ganesha is MD cache, which is metadata cache. So what it does is that with the latest Ganesha version, we have chunked caching, which means that if you are reading a very large file, it will not cache the whole metadata in, but it will cache in chunks so that the read response is faster. And so instead of always talking to the backend CephFS for the request, it will first check in the cache and then it will talk. So again, the response time should be better. If we see, there are two independent modules as well. There's admin dbus and logging. So using dbus, you can dynamically export and unexport the NFS Ganesha. So if you have a production cluster running and you don't want to stop the cluster, change something in the configuration file, and then restart the cluster, you can take advantage of dbus. So you can dynamically change the configuration. And then there's logging, which is for tracing and debugging. This slide just reiterates the fact that I just said. Now, few key features of NFS Ganesha are that using a single server, you can export multiple file system. At one point, you can export multiple protocols like TCP, UDP. You can also have multiple version of NFS, like NFS version 3, 4. And you don't need to have multiple instances of Ganesha running. You just modify a single config file and you can use the node. Then it also supports Kerberos authentication, and as I said, using dbus, you can dynamically export and unexport the entries. Those were the generic NFS Ganesha features. When we talk about CephFS, then there's support for CephX authorization, which means, so there are multiple layers of security. You have Kerberos security, then for CephFS, NFS Ganesha is a client, and there's this layer of security using CephX. Then the other feature which was recently implemented is read delegation, which means that the client does not need to talk to the server for every read request. It can just be, so the server gives guarantee to the client that if you're reading this file, and unless nobody is writing, you can continue reading. But in case someone is going to write to the file, there's a callback mechanism which makes sure that you don't read the stale data. And it also supports exporting subdirectories, which I think is really important in case you want to have a load balancing or you want to have proper security. So, but if we talk about a production setup, then of course a single server is never a good idea. You have a single point of failure, there's a bottleneck, and because we are re-exporting CephFS, which is a distributed file system, we are not taking advantage of that at all. The solution would be to use some HA solution which should provide us some load balancing. So when we talk about Linux HA, there are two possible solutions. One is active-passive and another one is active-active. So in active-passive, if there are n number of servers running, only one is actively serving the clients. In case the active server goes down, then the other server becomes active. But the new server does not guarantee that it knows anything about the client. So we do provide availability, but there's no guarantee that it will be consistent. The Linux HA provides a virtual IP, so you provide a virtual IP for the cluster of NFS Ganesha nodes that you have, and NFS client mounts using this virtual IP. In case the active node goes down, then the virtual IP also migrates. And for the client, it does not matter. It's still connected to NFS Ganesha, but it does not know that the Ganesha node has been migrated. So in NFS version 3 was a stateless protocol, which means that the server had no idea about the client state. But with NFS version 4, it's a stateful protocol, which means that the NFS server should know the logs taken by the client, the files opened by the client. And in that case, if you want to have a active setup, so in that case, we need somehow that the new server which takes over the clients of the failed server should have information about all the client state. And to achieve that, NFS Ganesha takes advantage of the already clustering solution provided by CephFS. So we're using Rados KV to store the client state. So let's say this server goes down, then the other active server should take up all the existing client of the failed server, and it can read up the information from the Rados KV, and then it can continue. Of course, there will be some delay in the response time, but that is something we will have to live up with. Now I will hand over to David to talk more about Samba. I must tell you I will be back. So.
Okay, thanks, Supriti. So yeah, hopefully you're also all aware of Samba. Yeah, in a nutshell, it does file and print sharing to, for the most part, Windows clients via the SMB protocol. It handles authentication with Windows with Active Directory. It does ID mapping, and it can act as an Active Directory domain member, or more recently a domain controller. The protocol itself, it's sort of split between the old ancient crofty SMB dialect, which was quite complex. It had a bunch of, or whole heap of commands, subcommands. It did include, at least for the Linux client side, it included extensions for Unix, which were quite helpful. But with Windows Vista, Microsoft sort of made a clean break from the previous SMB dialect, and brought in SMB2, which is much more simplified, at least initially. It sort of also offered some nice things like larger I/O sizes. Also more recently, in that it's still evolving over time, there have been some impressive new features added with SMB 3.1.1. We have now SMB Direct, which is sort of RDMA extensions for SMB. Multi-channel, so something close to MPIO with other protocols, with iSCSI or whatever. Witness protocol, so this is then allowing a client to monitor and receive notifications on the state of a scale-out clustered SMB server. Also, extensions for encryption. On the client side, we have, or at least alongside Samba, the most common one would then be Windows. One thing worth mentioning is that Microsoft nowadays do a great job in publishing the entire specifications for the protocol, so it's no longer such a arduous reverse engineering process. It's all done in the open. Mac OS, since Mavericks, I think they've used SMB by default, so also a common client. And with Linux, we have the in-kernel CephFS KO client and SMB client. There's also a more recent libsmb2 from Ronnie, which is interesting. With Samba or scale-out Samba, yeah, I think this was initially sort of implemented by IBM and Cernet, but there we had, or we still have, CTDB. So Samba for storing session state uses a database which is referred to as TDB, trivial database. In a clustered setup, we then obviously need to share this information across nodes participating in the cluster. So we have this CTDB, and that handles, so aside from the database, it also has basically a HA stack bolted on to handle monitoring, election of masters, failover within the cluster. I think I've sort of run through most of those points, but yeah, this is sort of how we then fit in alongside a Ceph cluster. So we have our Ceph gateway, which again, so similar to NFS Ganesha, we have with Samba a VFS or a file system abstraction where we can then just plumb libCephFS directly in there. That then just translates, or Samba then just acts as a translator from the SMB IO packets coming in to OSD MDS requests at the back end. And yeah, along the side there we have the database for storing persistent state. At this stage, with Samba we have this VFS Ceph backend, I think added by Inktank quite a few years ago. So that sort of, yeah, plumbs into most of the hooks that we have in the Samba VFS. It uses just static CephX credentials to authenticate with the Ceph cluster. So at this stage there's sort of no mapping between users and groups on the SMB side and what's used for the Ceph cluster. It supports POSIX ACLs, so Samba handles mapping between the NT or Windows NT ACLs and POSIX ACLs, and then we just stamp that attribute onto the files and directories. With CTDB, that requires what's called a clustered mutex helper, so that's then used for avoiding split brain within the cluster. So we have sort of just a standalone utility which uses just RADOS locks on the Ceph cluster. Also Ceph librados service integration, so this is something I'll hopefully push upstream soon. It just allows or sees Samba then advertise the availability of the service to the Ceph manager daemon. For testing, there's nothing sort of Ceph Samba specific at the moment or integrated, so for the most part I'm just continuing to use SMB Torture, which is quite a comprehensive protocol test suite. With the Linux kernel client, there's the XFS or FS test suite, and interrupt testing. For the most part, it's sort of more a manual process at the moment, but hopefully we'll get something more automated. Now on to performance.
So we did run some benchmarking for NFS Ganesha and Samba and how it performs with respect to a native CephFS kernel client. So this is what our benchmark setup looks like. We have 5 OSD nodes, 3 monitors and 6 OSD daemons per node, and we are using BlueStore. And we did run benchmark over 10 clients, and each client had 16 cores and 16 gigabytes RAM. The public network was 10 gigabit per second, and cluster network was 100 gigabit per second. For benchmarking, we are using file. So we are writing to data to a file of a specific size for a specified time. And we are running this benchmarking over the 10 client nodes. And one job type would look something like number of workers. And for each worker thread, we are running for these possible block sizes. And we did test only for the read-write at this stage. So if we have 10 clients, and on each client when we run only a single thread, then you have like 16 jobs, and at max we can have like 160 jobs. So for NFS Ganesha, I used NFS Ganesha version 2.5.2. There's already 2.6 tagged upstream, which has quite a few improvements over this version, so you should keep in mind when looking at the output. Ceph version 12.2.1, we tested with only a single NFS Ganesha server, and we mounted using NFS version 4.0. For my test, I was reading and writing to a 1 gigabyte file for approximately 2 minutes. If you see, then first, a full disclaimer that I did not disable caching, so the results are very high for both CephFS and Ganesha. In real life application, I would guess that people would be using caching, so in a way it's okay, but maybe we need to re-benchmark with caching disabled. If you see the output, then for single thread, Ganesha's bandwidth is approximately 80% of what native CephFS kernel client provides. But as number of threads increases, the performance degrades both for CephFS and NFS Ganesha, but more for NFS Ganesha. This is a more comprehensive read-write ratio bandwidth comparison for Ganesha and CephFS. So if you look at the first data point on x-axis, that is just a single thread, and then it's approximately 80% of what CephFS bandwidth is, but then it degrades. So it's obvious that as the worker threads are increasing, a single NFS Ganesha server is going to be a bottleneck, and in that case, we need to have multiple Ganesha servers taking care of multiple clients. This is the latency graph. As you can see, when number of threads increases, Ganesha's latency is of course higher. Now I will hand over to David.
Yeah, so for the Samba results, I'll just mention, that these are quite preliminary. So I've just been running these, up to the weekend. So the graphs I'm showing are sort of generated this morning. I'm running similar setup to Supriti for NFS. This is just with a slightly more recent version of Ceph Luminous. I have Samba 4.6 with 3 Samba gateways set up, all sort of exposing isolated parts of the CephFS directory tree. I have op locks or leases disabled, so that's currently one limitation of, or one of many limitations of the Ceph Samba setup. And I'm using Linux cifs.ko as the client with a relatively old kernel, but this has a bunch of backports on top, so it's the SLI or OpenSUSE Leap kernel. And I'm using the SMB 3.0 SMB dialect. So in this case, these are sort of the results I had for CephFS, aggregated bandwidth across all 10 clients. So sort of around 3.5 gigabits per second for read and write. with the Samba gateway. Oop, might have gone too far there. So there's, I think a considerable drop in throughput. These are sort of, I should mention, streaming. They're all streaming I/O tests, and then we just have a bunch of different I/O sizes. So 4K for the lower throughput results, 1 meg and 4 meg I/Os, and then we have 1 worker thread per client of 10 clients. 4 threads or 4 workers, 8 and 16 at the end there. So these are sort of the results I have to now begin sort of analysis and determine where the existing bottlenecks are. But at this stage, I think one of the, again, I'm sort of speculating a little without going sort of further into the detailed results, but at this stage, Samba uses or has a synchronous, fully synchronous back end for dispatching libCephFS IOs. So I think converting that from the synchronous back end to something which Samba also offers, which is sort of a pthread pool for local file system I/O. I think there we should see a significant improvement. The other one was caching or client-side caching. So SMB, the protocol itself, allows for sort of considerable caching and notifications of cache breaks. So similar to CephFS's native cache capabilities flags. So having some sort of mapping between these 2 caching mechanisms to then fully allow the CephFS or SMB client to perform caching would also, I think, significantly improve results there. So now on to challenges and sort of what we're currently working on, where we want to go with Samba and NFS as a gateway for Ceph. So at the moment we're sort of focused on cross-protocol support. I think at the moment NFS Ganesha is missing ACL support. So ideally we'd have ACLs on Samba, NFS, and the native CephFS client, all consistent. Coherent caching, so this is more just at least the Samba side that then needs to be improved to allow for leasing or SMB oplocks with CephFS. Unified authentication, so I think it was VMware upstream in Ceph were looking at adding Active Directory support as a replacement for, or as something alongside CephX. If that were to come in, then we could look at using basically the SMB client Active Directory or Kerberos tickets to then authenticate with that specific user with the Ceph cluster. So that's also something which would be nice to have. Async I/O at the Samba backend. That's one thing I mentioned earlier. I think there we would see considerable performance improvements. Multi-channel support. So this is the ability to sort of utilize multiple network interfaces on an SMB server and then sort of round robin or fail over between those interfaces. That's not currently fully supported with Samba, but hopefully that will then come soon. Deployment, so at the moment Samba isn't integrated into DeepC, which is sort of the utility we use for deploying a Ceph cluster within SUSE. Witness protocol, again this is very SMB specific, so allowing the Samba or Ceph cluster to notify SMB clients and sort of balance load across the SMB gateways would be something good to have. And finally, this replacement for CTDB, or potentially using the Rados key value store instead of a full HA stack would be, I think, a nice simplification for the architecture of a clustered Samba gateway, and something we're looking into. So now, NFS future, that's the last slide.
So upstream is already have started working on having clustering support in NFS Ganesha without using the Linux HA. So it means that there will be support in Ganesha to manage the clients. I think it's more targeted toward using Kubernetes with NFS Ganesha. Then another feature would be to have version 4.1 support, which means PNFS, and as a Librado service integration would also be nice. Thank you.
So I guess questions now. Yes, Owen.
NFS 4.2 and PNFS. I guess it's a bit going to happen with Ganesha, but is there any hope of this happening yourself?
Can you repeat the question, sir?
In NFS 4.2, the idea of striking the load across multiple nodes, getting away without a gateway. Yes. Is this coming, or is there any roadmap towards this in SAP? It's something that's well supported under the Microsoft kernel, and I believe also Blue Store supports it quite well. So it would be lovely to hear it coming through NFS storage system itself.
Okay, so the question is if PNFS is the near future of NFS Ganesha. No?
Not in Ganesha, just
But in Ceph. So,
or in Ganesha, however.
so I can answer for NFS Ganesha. So I would say yes, the upstream community is looking into having PNFS support.
So with Samba, there's, or at least the SMB protocol itself, it doesn't have anything similar to PNFS, or at least at this stage that I'm aware of. So I think the closest would be multi-channel, so just allowing the clients to sort of utilize multiple connections and round robin or stripe across them, but it's still very different to PNFS. Yeah.
I got a question.
Yes?
You mentioned the challenges you have, including HCLs and others.
Yes.
Looking wasn't listed there, I think. You have Samba, looking on Samba and looking over NFS. They're not really very compatible. Do you have a plan for this?
That's true. That's, I think, another task which needs to be addressed. Oh, sorry. So the question was, coherent locking between both NFS and SMB clients. So at this stage, we sort of support independent, isolated SMB and NFS setups, but yes, locking would be something that we'd like to have. Yes?
So what do you think, how far is the VFS implementation in Samba for production use?
So the question was, how close is the VFS Ceph implementation for production use? So I can say that within SUSE, we currently provide it as a tech preview for our storage product. I think if you're purely using it for Samba or to expose Ceph to SMB clients, then it's absolutely usable. So we found there have been a few bugs just with sort of certain operations getting through the VFS and hitting the local file system, but I think most of them are fixed. So it's getting there. Things like scalable performance, that would then be sort of a bit further out, I think. Any other questions? Otherwise, yeah, thanks for coming.
To the other position, this light takes a little bit to then eventually go green.
Yeah, green. So during the presentation, it should be green.
Yes.
Right?